Hello, we're presenting the work, The Reality of the Situation, a survey of situated analytics. This work is done in collaboration of University of Maryland, Bangor University, and Aarhus University. We started this work with the following goals. First is to understand how analytical processes are done in situ, and second, based on the understandings, to find gaps and opportunities in situated analytics. To do so, we needed to do three tasks. First is to characterize the design space of situated analytics. Second is to explore patterns existing in situated analytics architecture. And based on the 2 points, the third is to reassess the benefits and drawbacks of situated analytics using our characterization and pattern discovery of situated analytic systems in the literature. To accomplish our task, we conduct our work in the following manner. First, we define situated analytics. Second, we find relevant literature based on our definition. Third, with the literature, we create a design space for situated analytic systems. Fourth, we identify patterns and outliers in the literature. And lastly, we retrieve gaps and opportunities by analyzing what we did so far. First, here is the definition of situated analytics. First, that it represents data. Second, it uses interactive visualization. Third, it must be deployed using AR techniques. And fourth, it utilizes the user's physical location. And lastly, it must integrate analytical reasoning. In retrieving relevant literature, we first collected papers via keyword-driven search of the literature. Please look into the paper for more details. Second, we filtered papers based on our situated analytics criteria. With the papers, we created a design space. Here is how we decided to set our dimensions to characterize the design space of situated analytics. We begin with the 5W1H method. From this, we were able to obtain 4 dimensions. First, situating triggers describes when the system reacts. Second, view situatedness describes where the view is presented. Third, data depiction describes the type of data that is presented. And finally, sense-making support describes how sense-making is supported in situated analytics. We decided to leave the why and the who out of our scope. Next, we present these dimensions in more detail. Situating triggers refer to discrete events that lead to the instantiation or modification of a situated analytics tool. There are 2 types of situating triggers. One is reference and the other is context. Reference refer to spatial triggers that indicate a view should be instantiated or modified, such as location or object. Context refers to information surrounding the user at the time and space that triggers the data view or instantiation. View situatedness refer to the integration of data views into the world. There are 3 types. First is world registered, second is device anchored, and third is sticky. World registered refers to being positionally anchored to the real world. Device anchored refers to being linked to a specific location but persist in the periphery of the user's viewport even when this location falls outside of the current field of view. Sticky refers to being linked to a specific location but persist in the periphery of the user's viewport even when this location falls outside of the current field of view. Data depiction refers to forms that data representations take, such as visual encoding and abstraction. There are 2 types of data depiction. First is visual encoding. Visual encoding talks about how the visual representations are situated in the physical environment, such as 2D, 3D, or non-visual. Second is data abstraction. Data abstraction talks about visual expressions used for data representations, such as abstract, physical, or hybrid. Finally, sense-making support talks about the degree of which sense-making is supported in systems. This has 4 types. First is read. Those that belong to read are those that are capable of extracting data from visual representation. Second is explore. Those that belong to explore can not only read, but is capable of interacting with the data. We decide that the minimum requirements of SA systems are those that have the explore capability. Third is schematize. In a nutshell, schematizing is about marshaling where evidence is organized into a small-scale story. Finally, the last is report. Report is about organizing evidence and findings to create a coherent story. Based on these design spaces, we were able to obtain 47 situated analytics works and conducted analysis of them. Each situated analytics paper is represented as a binary vector of the features we developed. Then, we used an ensemble of various dimension reduction methods to extract 4 clusters and 2 anomalous works. This got us with 4 different patterns of SA systems. These are simulators, assistants, planners, and scanners. Type 1 simulators are an emulation of objects in situ. Examples include a system that imposes historical images onto matching views, or a tool for designing situated data visualizations. Type 2 assistants are location-specific assistants. They provide location-specific information to the user. Examples include a situated analytics tool that helps users to explore a university campus, and a tool that shows the X-ray vision of a location. Type 3 planners are interactive emulation, but constricted to a specific setting. Examples of these include a situated analytics tool where the user can find the optimal location for construction facilities, or a situated analytics tool that facilitates collaboration between people on different form factors. Type 4 scanners works as eyes that are augmented by the information provided by the device. Examples of this include a system that shows thermal changes over time, or a system that imitates bird and snake vision to highlight data of interest to the user. We have identified the following gaps using our taxonomy. First, that there are few systems that offer capabilities for schematizing and reporting. Second, we believe that there is the possibility to increase analytical capabilities. Third, we think that it is possible to build systems with more interaction. Fourth, we believe that systems can better leverage the capability of AR or MR's ability to depict compelling objects onto the world. Last but not least, we think that tools can be used across multiple tasks when existing tools are focused mainly on one task per tool. For more on discussion, please look into our paper, The Reality of the Situation, a survey of situated analytics, or come to our presentation at VIS 2023. Our session, Situated Analytics and Augmented Reality, takes place on Thursday, October 26, 2023, from 3:45 to 5 p.m. in room 109 at Melbourne Convention and Exhibition Center. We are more than happy to discuss with you more about situated analytics. Thank you.